The environment window is a collection of controls that are most frequently used. Instead of having them buried in the menus, we've broken them out for easy access. We are going to explore the 4 panels or tabs at the bottom of the environment window: the Pick panel, the Move Points panel, the Display List panel, and the Labels panel.
If I wanted this face from here, I hit F5 to here, F6, that face.
If you don't know how to use the function keys F5 and F6 to select parts as he's shown here, please watch the Selecting Parts video to learn the 4 ways to select parts in TrueGrid.
If I want that face to be projected to this cylinder, I need to select that cylinder. And there's several ways to do that. The first way is to go to the Pick panel and click on Surface. Then you use the mouse, left mouse button, click and drag to select that surface. Then you click on Project. Alternatively, I'll undo this. You can label the surface. You go to the Labels panel and tell it to label the surfaces. And then you go to the Pick panel and say that you want to pick by label. So then you have to find the label corresponding to the surface you want to project to. In this case, it's 1. You click on it and you see it highlighted. And then when you project, it does the same thing. I'll undo that. Now we've got a very simple example here with just 2 surfaces. When you import a CAD model, you are going to have more than 2 surfaces. You'll probably have more than 200 surfaces, and probably more likely 2,000. And we needed tools to be able to sort through them and to say, well, I want this surface and not that surface. Quite frequently what we do is pick all the surfaces that are in this box. And then I go to Display List, Surface, Remove. And do that 3 or 4 times. It's amazing how quickly you can whittle down a 20,000 set of surfaces down to the 5 that you're most interested in. There are other ways to do it as well. I'm going to show all surfaces again. And sometimes it's more advantageous to pick an edge. You come over here and pick the edge, and then you go to Display List and say Remove.
The display list controls the objects that are displayed in the picture. When you remove a surface, you are not deleting that surface. You are only hiding it.
There are many things we can do that with. Under Display List, we're going to remove a region. So I then click on Remove, and it takes that face off of the mesh. Now you might say, well, there's no brick elements on the inside. Well, we're not showing you the brick elements. We're just showing you the faces. And we're then taking one of the faces off. So it looks like a hollow box, but it's not. I'm going to hit F2 function key to get rid of the highlighting. And I'm going to enter or add the 2 surfaces back into the picture. So I go to Display List, Surface on the left, on the right, Show All. I need some curves. 3D curve. And then I'm going to create a spline curve. I'm going to pick by Z buffer. I'll pick some points and I'll save it. Curve number 1. Clear it out. Get rid of this. Get the LP3. Save it as curve number 2. And I want to show you how you use geometry, a surface, to manipulate your mesh. So the simplest one is using Z buffer. I can select a point on a surface. And if I select this vertex, now notice I'm going to move the mouse close to that vertex and hit F5. So I've selected a vertex, I've selected a point, and I say attach. We have moved that control point in our mesh, our vertex, to the coordinates that was selected by using ZBuffer. And the command that was generated is right here. It's the PB command. This is one of the fundamental commands in TrueGrid. It's basic. You select the object in the mesh, you select coordinates, and this object then moves to those coordinates. Now we can do it again. There's another point, attach. Another point, attach. It always goes to the last one. Now another way that we can use points off of the surface is to label the surface points.
One of the ways that we can select objects is by selecting the object's corresponding label. The Objects panel puts labels in the picture and takes them out of the picture. The Labels panel is tied to the Pick panel because to pick an object using the label, you must first go to your Labels panel and turn on the labels for your desired objects. There are many different objects we can display the labels for: beams, shells, quadratic shells, and curve points, for example.
Notice we have x, y, and z coordinates. If we turn off x and we turn off z, so only the y coordinate is going to be used. When I choose this vertex to be attached to this point, this labeled point right here, it's only going to change the y coordinate. So you see it's not actually at that location. And you can see from the command that it only attached to the y coordinate. And any combination will work. Here's another one. I'm going to move this vertex of the mesh. I'll hit F5 to this node. I'll turn on all three coordinates. I'm using the mesh as geometry. So I'm going to move this vertex to that location. And then it caused TrueGrid to rebuild that entire mesh. Typically, when I demonstrate these features, I never get all of them. There are just too many variations of this. So I say, if you think it should work, try it. It probably does. Now, another way that we can move the mesh around is with curves. So I will turn the labels off, and I'll use another feature called projection. That's not the same as project. It means we're going to use projection to select a point. And I'll first of all select this curve and then say projection. So when I click, it finds the closest point on this curve to where the mouse was clicked. Even if the curve is hidden, it'll still find the closest point on that curve as though it were visible. And when I've got the point I want, I then can attach. Well, that's ugly. So I will undo that. Not only can I do that with a curve, I can do it with an edge. So I'm going to pick an edge. I could come back to labels and have it label the edges so that I can pick a labeled edge. Or if I turn the labels off, I can pick an edge, use a little click and drag to select the same edge. So I can now click and it'll find the closest point on that edge to where I click the mouse. Now this time I'm only going to have it use the X coordinate when I select this vertex to be attached to this only in the X direction. We're going to go to the Move Points panel now. And this applies to several kinds of things. One is the mesh. We also can change the shape of a polygon surface when we're generating a spline curve. So I turned on point list, and now I can move this around by these rules right here. We have to choose one of them. For example, screen plane means that we're able to use the mouse to move it in a plane that is parallel to the screen at the point where it started. So whatever the coordinates are here, there's a plane that is parallel to this screen and passing through this point. So I can now move it in that plane. I could use front view. Now front view only works for hide and fill. And what it does is it moves on top of whatever is visible. On top of this. Now you have to be careful not to move it off of the objects because there's a back plane and it's a long ways away from where you wanted it to be. Or we can have it move only in the X direction. It won't move anywhere in this direction, only in this direction, or the Y or the Z, or one of the three planes. So when you choose to rotate something, you use the middle mouse button to find the center of rotation. If we choose region, we turn off any selection and do it in the screen plane. We can grab a vertex and move it all we want. Or we can select a face or an edge. Let's do an edge to begin with. And now we're going to move that edge, and it's going to move it as a rigid body. So it calculates the center of gravity of this object, and it moves relative to that center. And the object then is all moved as a rigid body. When you do a face, same thing. It's being calculated as a object with center of gravity, and that center is where you see the line starting on the mesh right here. And it's moving that center of mass to a new location. The whole thing is moved as a rigid body. So this collection of features are what we use to position the mesh so that when we do a projection, we get the desired result. Now, having said that, it may sound like you have to position it first and then project. Not the case. I will project a face onto this surface. This face is going to be projected to this cylinder. So I'll pick the surface and project. We have to change this in order to get the desired result. First of all, I'm only going to show this. I'm going to get rid of everything else in the picture. Region show only. So only this face is showing. And then I can move one of the vertices. I can move that. I'll move this one here. So I'll move this one over to here. And this one. Okay, so now I've got something a little more reasonable. Still not very good, but it's not spaghetti. Now, you're not supposed to use these tools the way I am. You're going to make reasonable choices to get reasonable results. This is just to demonstrate the huge flexibility you have in changing the coordinates before or after the projection. See, I just changed the initial position of some of the control points on this face after it was projected. And the result is as if I had changed the initial position of the nose before the projection. It doesn't matter what order it's done in. TrueGrid always moves things to their initial coordinates first and then projects. You need to practice this. These are going to be your basic tools, everyday use when you're building a mesh. Now, it was easy for me to select a surface and have it removed from the picture. But how do you add a surface to the picture? If it's not in the picture, you can't select it. And that's why we have a host of commands that control what objects are in the picture. And only some of those functions are available under the display list. This set of commands you see in this table control all the different objects that can be in the picture. And we're going to start by talking about the commands that control which surfaces are in the picture. The first command, the most basic, is dsd. It stands for Display Surface Definition, followed by one surface number. And when you issue this command, when it has finished executing, only one surface will be showing. That's the surface identified in this command. DSD, Display Surface Definitions, or definition, excuse me, singular. Now, if you want to add one surface to the picture, you use ASD, followed by a surface number. If you want to remove a single surface, RSD, followed by the surface number. Now, suppose you have a list of surfaces you want to show. Well, then you use DSDS for a plural. And then you give it a list of surfaces, ending it with a semicolon. And then that list of surfaces will be the only surfaces showing in the picture. Now, if you use ASDS, it's like ASD, except it's plural. And it adds a list of surfaces, and that will be added to the picture. And you end that list of surface numbers with a semicolon. And then you have RSD, that's this command here, for a single surface to be removed, but here it's plural, RSDS. And so you remove the surfaces listed ending with a semicolon. DASD stands for Display All Surface Definitions. And RASD means remove all surface definitions. And these are the commands that we use to control what surfaces are in the picture. And some of these functions are available here. Well, you can remove one or multiple surfaces. You can show only one, you can show all, or show none. But you can't add surfaces to the picture other than to show all. That's why you need these additional commands. Now, these commands are found in the Surface menu. If we go to the main menu and then to Surface, you'll see them listed here. There's Display All Surface Definitions, Add Surface Definition, Add Surface Definitions, plural, Remove a Surface Definition, Remove Surfaces, Remove All Surfaces. There they are, these two also. So that's why there's so many commands under this menu. It's just that we have many ways in which we want to control what's in the picture. Well, that's the case for surfaces, but we also have 3D curves. But if you know how to do the surfaces, it's an easy mission to do the same for 3D curve, because instead of having an S surface in these commands, put a C. And otherwise, there's a perfect parallel of controlling 3D curves so we control what surfaces are in the picture. Go to the 3D curve menu, we will see all 8 of these, 2, 4, 6, 8 of them, in the 3D curve. Well, that's not everything. When we build complicated models, we might have many parts, and we may only want certain parts. Control what parts are placed in the picture with this set of commands, and it's very similar to this set of commands. Here we have an SD at the end or sometimes in the middle of the command standing for surface definition. Replace that with a P. And now we have 8 commands that we can use to control what parts are in the picture. Point here. In TrueGrid, a part result of a block command. There are several other part commands. Basically, the idea is you've built a part based on a set of connected blocks. So a material in TrueGrid is very different than a part. You can have a part that has many different materials, or you can have many parts that have the same material. When it comes to controlling what materials are in the picture, replace the P in the parts commands with an M for materials. And then there's one more. We're going to skip these. It's never used. And that's block boundary interfaces. They're objects as well, and they too are controlled. The block boundary interfaces that show up in the picture are a result of these commands. And instead of M in the material control commands, use BB for block boundary. And you now have a repertoire of 2, 4, 5 times 6 times 8, 40 different commands that control what's in the picture. Each category of such commands are listed under their corresponding menu. So for example, if we go to 3D curves, here you see those commands for controlling what's in the picture. And if we go to interfaces, here are the block boundary commands that control what blocks or block boundaries are in the picture. When, for example, you say dsds, this means to display surface definition. So it's a list of surfaces followed by a semicolon. But suppose that that list included a sequence. For instance, in this case here, surface 19, 20, 21, 22, all the way up to 29. You can shorten that specification or that list by having a colon between the first and the last. And that's true anywhere there's a list of numbers.